All right, here we go. New material. Section 8.1.3. 8.1.2 we kind of skipped because it was just more mean and median review. If you don't know what mean and median is, you can go back and watch the previous video and kind of review what that stuff is. But looks like for the most part you guys are doing well with that subject. I've got to just see a few of them as the alerts have come across on my phone, but the discussion that you've been having today with your learning log question, the ones I saw at least, there were some good answers there. So today we're going to get into something called mean absolute deviation. If you abbreviate it, it spells mad. So take some notes, get your journals out, pause the video when you need to, write down information so you have it, and we'll kind of walk through what this whole thing's all about, okay? So if we were in class, of course, we would have an objective, right? We want to be able to make sense of a set of data, including the spread, or also known as the variability, by using mean absolute deviation. So variability and spread, that's one of the key things that mean absolute deviation helps you figure out, okay? So I've got a couple examples here. You may be wondering why Mr. Scove is there. Well, this set of data, actually we've got two sets of data, game 1 and game 2. These are basketball scores. So realize there's no sports really going on right now, so this is about as good as it gets with sports at the moment. So Mr. Scove's on there because, of course, he coaches the boys basketball team, right? So I put a picture of him on there. But Mr. Scove has gathered the data from a couple of his last 2 basketball games, okay? And each square on this data represents a player. So in game 1, he had 10 players, and it looks like all 10 of them scored, which is good, right? Spread the scoring out, make your team hard to stop. And in game 2, the same thing. All 10 players were able to score. So what I want to do, first of all, and this will just be a brief review for you, hopefully, but I want you to get some practice in, and I want you to determine, so this is where you have to stop the video, do a little bit of calculation, and then come back. Tell me, what is the mean for game 1, the median for game 1, and also what is the range of the data for game 1? And then you're going to turn around and do the exact same thing, get the mean, median, and the range for game 2. Okay? So pause the video, solve that, then turn it back on. Got it? You're not cheating now, are you? Okay. I'm trusting you that you actually did the work, right? All right. So, well, we'll get to that question in just a second. If you did the work, you basically came to the realization that the mean, the median, and the range for both of those games was 10 for all 3 of those, right? So the mean was 10, the median was 10, and the range was 10. So now I can bring up that question that I just pulled up, which was, is the scoring in those 2 games equivalent? So we can kind of use those measures of central tendency, mean and median, the average, the very middle number, and even the range in this case, they're all the exact same. So if we look at just those 3 things, we can say, well, yeah, it looks like the scoring in those 2 games was pretty equivalent, right? But we don't know a lot about how the scoring was spread out, right? We know that it was about the same. We know that both games had the same total amount of points scored, but we don't know what is the variability of the numbers that each player scored, right? We don't know that much from this. So that's where mean absolute deviation is going to come in. So here's a definition for you. Mean absolute deviation is the average distance that each data point is from the mean. Okay? So write that down in your notes. That's an important definition to have so you can explain on your math notes quiz what mean absolute deviation means, okay? The average distance each data point is from the mean. So, there's basically kind of just 3 key steps that we're going to go through, okay? First of all, step number 1 when you're trying to determine what is the MAD. So let's just use MAD. It's a mouthful to say mean absolute deviation, right? So let's just use MAD. If we're trying to calculate MAD, first step we have to do, we have to find the mean of all the data that we're working with, okay? Step number 2, we have to find the distance between each data value and the mean. So this is where that word, the A, absolute, when you think back to absolute value, we learned that absolute value meant how far away is a number from 0, right? Doesn't matter if it's a negative number or a positive number, all we care about is how far away is it from 0, right? Same concept applies here for MAD. The only difference is we're not saying how far away is it from 0, but how far away is it from the mean. Okay, so once you've calculated the mean, you then have to go back and say how far away from the mean are each of these data points. Okay, that's step number 2. And then the third step is you have to find the average of those differences. Okay, so you're going to calculate how far away they all are from the mean, and then you're going to calculate the average of those things, and then you have your mean absolute deviation. Okay, so let's walk through an example. I know that's somewhat confusing right there. Well, first of all, let's talk about this, and then we'll do an example, okay? How is MAD used in the real world? Because it seems like kind of a crazy concept, right? Well, a couple things I put up here. First of all, teachers. That's the obvious answer, right? Every time, of course, a math teacher is going to teach MAD, right? But teachers use mean absolute deviation, but not specifically just to teach the concept, but to say, okay, say I give you a test, and I want to know, was my test too hard for the students, or was it too easy, or was it just right? And if I do mean absolute deviation, it can help me figure that out, right? Do I need to make my test more challenging, or should I make it a little easier, or was it good to go the way it was, right? Biologists, for example, biologists can use MAD to compare animal weights to determine what is a healthy weight for a particular species, right? Or what's the appropriate weight for that species. And finally, another example is coaches. Okay, so like Coach Scove there in the beginning, he can use MAD to determine which player is the most consistent, right? So he can go from game to game and see which player is the most consistent, right? So for example, maybe Donovan Mitchell scores around 20 to 24 points per game, and you can pretty much count on that almost every night, right? But then you throw in somebody like, I don't know, I'm trying to think back to before basketball got canceled, maybe like Bogdanovich, right? That guy can shoot the lights out, but at times he was a little bit inconsistent, right? He could score 40 in a game, and then maybe the next night he only scores 5 points, right? So consistency, right? A coach can use MAD to kind of figure out consistency of a player. So let's go ahead and, in fact, we'll use this slide right here. We're going to calculate the mean absolute deviation using the data from Coach Scove's game number 1, okay? And so we've got 3 columns here. We've got the data value, which represents how many points did each player score, right? Player 1 scored 4 points. Player 10 scored 14 in the game. We're going to find out how far away from the mean is that value, and then what is the absolute value over here, right? So this step right here maybe isn't always necessary, but it kind of just helps you visualize that we're talking about absolute value, right? Doesn't matter negative or positive, it's just how far away, okay? So the first 2 here, player number 1 scored 4 points in the game. Well, we know that the mean was 10, okay? So we already did step 1 of MAD. We calculated the mean. The mean of all of this data is 10, okay? Now we got to say how far away from 10 are each of these data points, okay? 4 is 6 smaller than 10, right? So they put a -6 there. But the absolute value of -6, if you remember the little absolute value bars that we would put around these numbers, that's your signal for absolute value. Absolute value of -6 is 6, right? The absolute 8 is 2 smaller, so -2 away from 10. Absolute value of -2 is 2, okay? 9, for example, 9 is 1 spot away from 10, right? It's 1 smaller than 10, so -1. The absolute value of -1 is 1, and so on, okay? If you feel comfortable and you want to just finish this out on your own, go ahead and pause the video, finish it, and then you can jump back with us, okay? I'm going to skip doing the difference from the mean right here because I know absolute value is always positive. So I'm just going to write down how far away from 10 is it, and I'm going to put the number here, okay? So look right here now, we've got the next 3 digits are all 10 itself. Well, those are exactly 10, so they're 0 away from 10, okay? 11 is 1 spot away. 12 is 2 spots away. Again, another 12. And 14 is 4 spots away. Okay? So step 1, calculate the mean. We did that. Step 2, calculate the differences. How far away from the mean are all of the pieces of data? We just did that, right? Step 2. So the last part of that step 2 is just simply to get a sum and to add up all of those values. Okay, so if we do that, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So the sum is 18. And then the last step was get the mean of those values, right? So again, the mean, as we know from previous lesson, the mean means take the total of everything, which is 18, and divide it by the total number of data that you're working with. So we know we have 10 players, they each scored, so we have 10 pieces of data. So it's basically 18 divided by 10, right? And if I were to if I calculate it out, do some long division, however you want to do it, I'm going to come up with a value of 1.8. Okay, so the mean absolute deviation, the MAD, of Coach Scove's game 1 was 1.8. Okay? So basically, that's a terrible 8. So basically what that tells us is, on average, each player is around 1.8 points away from the average. Okay? Which is actually pretty good, right? If we have a fairly low deviation like that, it means all the players are scoring pretty close to the same amount, right? So that's a good thing to have. So let me see. Okay, so that's basically it in a nutshell. I'm gonna stop there on this video. If you would like some additional help, I'm also going to attach some links to some Khan Academy videos. Sometimes just hearing it from another perspective, it can kind of click a little better than what I show you here. So it's not going to hurt my feelings if you didn't get this and you do want to go look at Khan Academy, and then it does make sense, right? So take a look at those videos. In the Khan Academy example, he does go into a little bit more detail as far as like he made like some dot plots and some things to go along and kind of explain it a little more in depth. So take a look at those. And then haven't decided what I'm going to have you do yet for homework, so I'll let you know. Check Canvas, right? It'll be there for you on Tuesday. Okay, guys, take care. Be good. Bye.